This video is the continuation of why do we need factoring. It says, use the factored form of each quadratic to find the x-intercepts. The graph of the function, then graph the function on a graphing calculator or Desmos to confirm the x-intercepts. Well, we're just going to find the x-intercepts and I'm going to show you where they are because I know what this graph is going to look like. We discovered in the previous part of this lesson that we can find x-intercepts for a quadratic function, but only from the factored form. And so we want y to be 0 because we know that no matter where the x-intercepts are, y will be 0. So either this factor has to be equal to 0 or this factor has to be equal to 0. So in other words, x minus 7 has to be equal to 0 or x minus 3 has to be equal to 0. And most people, they know that they can just put 7 in here. But if we were solving, we would be doing the inverse of subtracting, which is adding. And so x would equal 7. So our first x-intercept is at 7, 0. And it's that inverse operation of subtraction and addition that makes the sign of the value for the x-intercept the opposite of the sign here, that inverse operation when you're solving the equation. And the other intercept is at 3, 0. If I were to graph this, 3, 0, 7, 0, there's my graph. I'm not really concerned with how low the parabola goes or how wide or how skinny it is today. I'm only concerned with these two intercepts. For example E, I am going to take this factor, 2x plus 3, set it equal to 0, and this factor, x plus 1, is equal to 0. I'm going to subtract 3. There's that inverse operation. So 2x is equal to negative 3. And then I'm going to divide both sides by 2. So x is equal to negative 3 halves. I'm going to subtract 1 from both sides, and x is equal to negative 1. So both of my x-intercepts, we'll make this negative 1/2, negative 1, negative 3 halves. Both of my x-intercepts are on the negative part of the x-axis, and the parabola would look like that. What you probably don't realize is that you've been using the ZPP all along. ZPP stands for zero product property. It says that if two factors, a and b, equal 0, then either a is equal to 0 or b is equal to 0. If two factors have to equal 0 so that the y value of this function is 0, then either this factor equals 0 or this factor equals 0. You take each factor, set it equal to 0, and solve for x. So in other words, you take each one of these factors, and x plus 3, set each one equal to 0, solve for x, solve for x, now these two numbers here, x equals 5/4 and x equals negative 3, these two numbers, these are called solutions. If I then use these numbers in an ordered pair, then these are the x-intercepts. And if you're reading online or in a textbook to look for extra information about x-intercepts, sometimes you'll find out that these two numbers, not only are they called solutions, but they're called roots for the quadratic function. I'm not sure where that term comes from. I just know that it's out there. And then they're also called the zeros of the function. Now this makes sense. These two solutions would be called the zeros of the function because if you use these as inputs, your output is going to be 0. So now that we finished that page, let's summarize. What is the relationship between the quadratic function and the x-intercepts? Well, we know that the factors can tell you the x-intercepts. Standard form won't work. So instead, we need to have the factored form so that we can find those x-intercepts. What is the zero product property and how do you use it? You set each factor equal to 0 and solve for x. So in other words, if I had f of x is equal to x minus 1 and, I don't know, 10x plus 3, then I would take this factor, x minus 1, set it equal to 0, and this factor, 10x plus 3, is equal to 0, and I would solve for x. And what happens when you substitute the x coordinate of one of the x-intercepts into the equation? Why is this always true? Well, it says one of the x-intercepts. It really could be either one of the x-intercepts. If my x-intercept, for example here, my x-intercept would be at 1, 0. If I take this input and I find f of 1, the output will be 0. Okay, that's it for today. Your job then is to go to the Check for Understanding with the extra challenge at the bottom and do your best. And then check your work online. Thank you.